Hello guys, this is Daniel and today we're going to continue with a guess the number game. This is an improved version of the game in which we are able to have several games supported by the same contract. Remember that the requirements of this game are that whenever the game triggers a payment, either because someone guessed the right number or because the game has more than 10 wrong guesses, or basically 10 wrong guesses, then 99% of the funds goes to either, in the case of a right guess, to the person that made that right guess, and in the case of the 10 wrong guesses, to the creator of the game. But the remaining 1% of those payments goes to the person that is providing infrastructure, which deployed the contract. So today we're going to implement the next function that we have pending. We already created our structs and hash maps that are allowing people to create several games in the same contract. And we create a function that allows us to actually create games. Then we create some view functions already to view the balances, the game guesses, and whether the game is active or not. And right now we're going to work in the function that allows people to play, but only in the case of a right guess. We are not going to work in the wrong guess yet, or in the case that you have the 10 wrong guesses, right? So let's start. We're going to have a function that is going to be external. It needs to be payable. It's going to be called def play game. And this function is going to receive the following parameters. We need to have a parameter for the game ID. So this game ID is going to be a uint 256. The other parameter that we need to pass is, of course, the guess number. And that's also uint 256. We need to return something in this function, and what we're going to return is going to be a Boolean value. If everything went correct, we're going to return true. So this is what we're going to do here. Now we need to do some confirmation. Whoever is playing a game has to pay 1 ether, right? So we're going to do that assertion first. We're going to assert that the message value is equal to 10 times, well, not times, 10 to the 18th way, that's 1 ether. Now, the next assertion that we need to do is that the message sender should be different to the person that created this game, because if that's not the case, he might know what is the secret number. This is not the right implementation of this specific assurance, because obviously anyone can play from any Ethereum addresses, right? So this is going to be moot because of that fact. To actually implement this game in a production setting, we need oracles, which is a topic that we're going to touch in the future in this series, in this channel. Now, we have that assertion there. The other thing that we want to assert is that the game should be active, so that's going to be self game index, and the game ID is game active should be equal to true to play. If this one is false, then we are not going to be able to play, right? Now we need to start executing the function, and for that we need some assignments first. We are going to update the balance of the game with the value that was transmitted, so we're going to say self game index game ID that get that game balance. It's going to be equal to same thing to itself plus the message value, right? So this is the first thing that we need to assign. Then the other thing that we need to do is to increase the guess count. So we're going to do that with the game index, game ID, guess count. Let's check that we are using the correct variables, because I'm not very sure about that. So we have guess count, game balance. Yeah, perfect. We are working correctly here, and this should be equal to itself plus 1. So we are basically just increasing the variable of the guesses. Now we need to implement the logic, right? And what we want to do is to be able to verify if the guess is correct. So we're going to say if guess number equal to, and then we're going to do self game index game ID, curly brackets here, not curly brackets but regular brackets, game ID that secret number. Then what is the logic that we need to have, right? And the logic that we need to have here is that the funds have to be transmitted to the person that make the right guess and to the contract owner, because he provided the infrastructure. That's the 99% and the 1% that we were talking about before. Send, and then we're going to check the message sender first, and then to this person we are going to send 99% of the game balance. So the way to do that is that we are going to add this, and we are going to say self game index game ID game balance times 99 divided 100, and this is 99% of the game balance. Now we also need to send the balance to the contract owner. So we had a variable to identify the contract owner that we have here at the beginning, contract owner, that we are populating at the moment that the contract is deployed. So we're going to do that one. We're going to do self contract owner, and then to this person we are going to send self game index game ID balance, what we did before, divided 100, that's 1%. Now that we have taken care of this, then we need to do some resetting of the variables to get the contract in the right state. So for that we're going to do self game index game ID that game balance is equal to 0, because the entire balance of the game was transferred to the person that made the right guess and to the contract owner. And then we have to deactivate the game. So we're going to do game index game ID that is active, we set it to false. And that's it, guys. That's basically the content of this function, only for making the right guess, right? Now we need to test it, so we're going to do Brownie console to compile and test. And this is happening because the variable is called is active, is not is game active. So let's just get rid of that one here. Let's close this lint, which is a little bit annoying. Let's do clear, and let's do Brownie console again. We have to return some value, because we said that this function is going to return a Boolean, so we're going to return true. And then let's return to our development. Let's do Brownie console. We are ready. Now let's do a deployment. So we're going to do a guest game 201 that deploy, and we are going to deploy from address 0. So let's go to curly brackets for sure, then from accounts 0. Let's deploy the game. We got our response back. Now remember that for getting access to the functions of that deployment, we need to refer to its index, and then let's do the function calling. So we're going to do create game. And for create game, we need uint, which is a secret number. So let's say that our secret number is going to be 9. And then we need to create our parameters for sending transaction. So we're going to do from, and then this is going to be accounts 1. And we are going to create a game. So for that, we need to submit a value of 10 Ether. As you remember, that's the price to actually create a game. So we are deploying from account 0. We are creating a game from account 1. So create a game. So got a response back. So we created a game. Now let's play. And play is going to be very similar to this one. So let's do this. We are going to do play. We are going to play a game 0 because we just created that one. We are going to submit a wrong guess first. So it's going to be 8. And we're going to play from account 2. And we're going to pay with 1 Ether. Let's submit our play. And of course, it's not named a play, it's play game. So let's do play game. And we play 1 time. Let's play 2 times. And now let's check what is the balance. So for that, we have a function here that is called get game balance. And for calling that one, we have to submit an index. So we have here the 10 ETH that were sent when the game was created, plus the 2 wrong guesses. And then if we go to the guy that play, we are going to get his balance in his account. So we have accounts 2 that balance, and he had 98 ETH because he already made 2 wrong guesses, and Ganache give us 100 ETH to begin with. Now let's do a little bit of checking of the account 0, which is the account that created the contract, which is the owner right now. He has 100 Ether as initial setting from Ganache. Now let's do a play, but we're going to play guessing the right name, also from account 2, right? So let's do the right guess here. We confirm that a transaction is back, and then let's check the balance. So for this guy that made the right guess, we got almost everything that was in the contract, right? But that it's not all the balance that was in the game, only 99% of that balance. If we check the account 0, this guy goes the other 13, which is the 1% of what was in the actual balance of the game. And if we get the balance of the game right now, it should be 0. So guys, this is the very basic function that we use to play. We are going to be building upon this in the future. Hope you have enjoyed, and smash that like and follow the Morales channel.